Hello everyone. If you observe this question here, so this question was asked in 6 April 2026. So now the question is, so here they given different types of orbitals and here they given different types of nodes and we should match that. They asked radial nodes and nodal plates. So simple radial nodes is equal to n minus L minus 1. So here n equal to principal quantum number. N equal to principal quantum number. And here L equal to azimuthal quantum number. L equal to azimuthal quantum number. So L values indicates if L equal to 0, S orbital. If L equal to 1, P orbital. If L equal to 2, D orbital. If L equal to 3, F orbital. So N is a principal quantum number. So N equal to K, L, M, N, O, R 1, 2, 3, 4, 5 ... like that, guys. Means N indicates orbit number. So for finding radial nodes, formula is nothing but n minus L minus 1. Now, and also they ask nodal planes. Nodal planes are nothing but angular nodes. What are, guys? Angular nodes. Angular nodes are always equal to L value. Angular nodes are always equal to L value. So now here they given 2s orbital. For radial nodes, n value 2 minus L value 0 minus 1, because the formula n minus L minus 1. So 2 minus 1, 1. And for angular nodes, so that is equal to L na. So for s orbital, L value is 0. Means there is a 1 radial node and 0 angular node or nodal plane. That means for A option 4 will come. So means option 3 is wrong. Then how to move? Option B. They given 3s na. So for 3s means n value is 3, L value is 0 and minus 1 na. So means we will get 2 radial nodes and 0 angular nodes. That means option 3 for B. Only one option is there, that is option 4. So option 4 is the answer. It is simple question. So radial nodes is nothing but n minus L minus 1 and angular nodes is nothing but L equal to L value, guys. I given L values for different orbitals. So based on that we can easily get answer for like these questions, guys. Okay students, if you observe this question, they given two statements. Here statement 1 is 2,6 diethyl cyclohexanone and 6-methyl 2N-propyl cyclohexanone are metamers. First we should understand metamer. Metamer means same functional group but attached alkyl groups are different. Here CO is a ketone. So if you take C double bond O and R double dash and R triple dash, means it is a R one type of alkyl group, R dash is one type of alkyl group, R double dash is one type of alkyl group, R triple dash is one type of alkyl group. If formulas of these two is same but attached alkyl groups are different, then those are called metamers. In the question they given 6-diethyl cyclohexanone. First we should draw the structure. This is cyclohexane, this is cyclohexanone. They given 2,6 diethyl. So at second position there is a ethyl group and at sixth position also there is a ethyl group, C2H5. Now I have to take another one, 6-methyl 2N-propyl cyclohexanone. So look here it is cyclohexanone. It is 6-methyl means CH3, N-propyl CH2, CH3, CH2, CH3. This is the propyl group. Now if you observe these two compounds, here the functional group is CO. One side of the functional group, one type of alkyl group is there along with C2H5. Another side is also with the C2H5 group is there. Now if you observe second compound, one side of the CO functional group, there is a propyl group. other side there is a methyl group. In case of first one, both are ethyl, but in case second one is methyl, another one is propyl, guys. Means different alkyl groups which are attached to functional group. Means these two are considered as metamers. Means option 1 is correct one. Statement 1 is correct one. Now how to move statement 2. That they given 2,2, 6,6 tetramethyl cyclohexanone exhibit keto-enol tautomerism. So, for example, how to take any ketone like this, CH3, CO, CH2, CH3 is there. Now, C double bond O is a keto group. Adjacent to that C double bond O, alpha carbon we called. So, now there is a alpha hydrogen. Oxygen is more electronegative than carbon. So, it attract electrons towards itself and will get minus charge. That's why that alpha hydrogen gets attached to that oxygen and will give CH3, C, OH. Here we get double bond CH, CH3. So now this is keto form because keto functional group is there now. Now it is double bond and OH is there now. Now it is enol form. Means if you observe here, if there is a alpha hydrogen, there is a chance to involve keto-enol tautomerism. If it have no alpha hydrogen, there is no chance to involve in keto-enol tautomerism. So means first we should construct structure of compound in the given statement 2, guys. So the structure is the given 2,2, 6,6 tetramethyl cyclohexanone. This is the cyclohexanone. Second position methyl and second position methyl. At sixth position also methyl and sixth position also methyl. This is the tetramethyl cyclohexanone. Now this is the keto group. Now adjacent position is alpha. Here adjacent position is alpha. Now if you observe here, this carbon is with 4 bonds. 1, 2, 3, 4. Here this carbon is also with 4 bonds. Look here, 1, 2, 3, 4 bonds are there. Means these two carbons have no hydrogen. Means this ketone have no alpha hydrogen. Means that one not involved in keto-enol tautomerism. Means statement 2 is wrong. That means both statement and statement 2 are true is wrong. Both statement 1 and statement 2 are false is also wrong one. Statement 1 is true but statement 2 is false. That is the correct answer, guys. I hope you understand. Now look this question. This is also match the following like this question, guys. So one side list 1 they given different electronic configurations. Another side they given crystal field stabilizing energy of tetrahedral complex. They given delta T. We should find CFC values of given tetrahedral configurations, guys. First we should understand one thing. So we know d orbitals are 5. D orbitals are 5. These 5 d orbitals are degenerate orbitals. Options of any external magnetic field or external electric field. When we apply external magnetic field or electric field, these 5 d orbitals are split into 2 categories. So category 1 is T2Z we called. Category 2 is called EZ, guys. EZ orbitals and T2Z orbitals. DXY, DYZ, DZX orbitals are called T2Z orbitals. Dx square, y square, dz square orbitals are called EZ orbitals, guys. Why T2Z gets more energy in case of tetrahedral complexes means, so in case of whenever ligand try to approach central metal atom, in case of tetrahedral, it approaches between the axis. That's why the orbitals present between the axis are T2Z orbitals. So why those orbitals will get more amount of energy than the orbitals present on the axis, guys. That's why T2Z gets more energy and EZ will get lower energy, guys. Now for tetrahedral complexes, so EZ is lower energy and T2EZ is a higher energy with 3 orbitals. EZ with 2 orbitals, guys. So first they given D2. And one thing you should also understand. If electron enter into the EZ orbital, that complex will loses minus 0.6 delta naught energy. If electron enter into the T2Z orbital, that complex will get 0.4 delta T energy. Delta T energy, guys. So D2 means first lower energy, 1 electron, 1 electron. Both electron will enter there and they will losses minus 2 into minus 0.6. That means minus 1.2 delta T energy they will lose. So means for that minus 1.2 means for A option 3 is the correct. For A option 3 is the correct means option 4 is wrong option. Now how to take option B. In case of option B, D4 is there, na? D4 means EG, there are two orbitals, na? So 1, 2, 3, 4. If there is a strong ligand or low spin complex, we will get 4 electrons in EG orbital. Means 6 4s are 24 minus 2.4 delta T energy will loses that complex. But in the options, they are not given minus 2.4 delta T energy. Means that the complex must be high spin complex. Now how to take D4 complex like this. So EG T2Z how to take. EG 2 orbitals, T2Z 3 orbitals, guys. 1 electron here, 1 electron here. Now 1 electron T2Z, 1 electron T2Z. Means here in case of EG minus 1.2, in case of T2Z for 1 electron 0.4 delta T, na, there are 2 electrons means plus 0.8. The resultant answer is what? Minus 0.4 delta T. Means for that option 4. So A is for 3, B is for 4. B is for 4 means option 2 also wrong. Now how to move C, D6. How to take D6. So now here EG orbital. Now here I have to take T2Z orbital. So here 1, 2, 3, 4, 5, 6. Here 3 electrons are entered into the EG orbital. Means 3 into minus 0.6. That is nothing but minus 1.8 delta T with respect to the EG orbital. Now here 3 electrons are entered. So means 3 into 0.4. That is nothing but 1.2 delta T. The resultant will become the difference between minus 1.8 and plus 1.2 is nothing but minus 0.6 delta T, guys. So means for C option 1, for C option 1, for A option 3, for B option 4, for C option 1 means the absolutely answer is option 3, guys. So like that we can calculate CFC values of different complexes, guys. I hope you understand solution of this question. If you understand solutions of these questions, just like this video, if you are new to this channel, you have to subscribe this channel for more videos, guys. See you in next video.